Set up, but do not evaluate, an integral that represents the length of the curve. X equals the natural log of t, y equals the square root of t plus 1, t ranges between 1 and 5. This is a set of parametric equations which define this curve, and in order to find the arc length, we use the arc length in parameterized form, the integral from a to b, square root dx dt squared plus dy dt squared dt. So we just need to find a few things since we only have to set up the integral. We really just need to find a and b. Those are our limits of integration. That's quick enough to do. This is 1 to 5. But we also must find dx dt, the derivative of x with respect to the parameter, and dy dt, the derivative of y with respect to the parameter. We can do that. Let's go ahead and rewrite x and y down here so we can have them close. X is equal to the natural log of t. Y is equal to the square root of t plus 1. So dx dt, we know the derivative of natural log of something is 1 over that something, so the derivative natural log of t is 1 over t. For dy dt, it would probably benefit us to rewrite the equation for y. Y is equal to t plus 1 to the 1/2 power. Then we apply the power rule with the chain rule. So dy dt is going to be, we bring down the power, 1/2 t plus 1, then we subtract 1 to the negative 1/2, times the derivative of the inside. Well, in this case, the inside is the t plus 1. The derivative of t plus 1 is just 1, so really for us, we're just going to multiply by 1, which is not absolutely necessary, but we write it just for clarity. Okay, so there's our dx dt, our dy dt. Again, we know that t ranges from 1 to 5, so we're ready to write the integral, which represents the arc length. So the arc length is equal to the integral from 1 to 5, square root dx dt squared, so 1 over t squared, plus dy dt squared, that's 1 over 2 square root of t plus 1 squared dt. Remember that whenever you have a negative exponent, that drops that factor into the denominator. So the t plus 1 to the 1/2 is going to come down with the 2. Then the 1/2 exponent, just as we did above, the 1/2 exponent is the same as the square root. So that's how we can rewrite that. We could do a little bit of simplification here. We're not really asked to, but just in case, notice that, erase that red. Notice that we can end up with the square root of 1 over t squared is the same as 1 over t squared, plus, and when you square the 1 over 2 square roots of t plus 1, you're going to square the 1, which you get 1, and then you're going to square the 2, which you'll get 4, and then when you square the square root, the square and the square root goes away, so this is t plus 1. So that does look a little bit cleaner, but it doesn't get us very far. Nevertheless, we're only asked to set up the integral required to find the length of the curve from 1 to 5.